For this lesson, we're going to calculate the area of a circle and its circumference. So, the key ingredients here are the algorithms that you're going to use to process the input as a radius. So you're going to input the radius as a value from which you will distill what the area will be and what the circumference will be. So what I have done here is, in the comment, I put in the actual formula for area, which is pi r square, where r2 here is radius square. Now this is not code, by the way. This is just simply a visualization of what the formula looks like. Okay? And then pi, again, as you can see here, is just a visual aspect of pi. It's not the actual value. We know that the actual numerical value is 3.14 and some dust. So this is an approximation of 3.14. We're going to use this for phase one of our calculations. We're going to have two versions of this program, where one we will work with the approximation, and where when we are ready to square, we're simply multiplying the radius by itself. Okay. Then the circumference is 2 pi r, where r again is radius. So just like we did in the previous lesson, we're going to break down our program into three distinct sections where we're going to handle the input. And basically, we're going to ask for radius from the user. We're going to process the input to obtain our results. And then, lastly, we will output the results. Okay? So these are the three main phases of writing a simple program. So the first thing we're going to ask the user is to actually enter the radius of that particular circle. So something like this: radius equals, now we know we could use the input function like this: input, enter the radius. Now the problem with this is that once it stores it in radius, it's basically a string. It's not necessarily a number, right? So let's prove that for a minute. Let me just output the radius here. So print the radius equals, and then we're going to put radius. By the way, we don't need a space there, and we could see here if we run this program, it's going to ask me for the radius. So let's say I enter 1.3 or 2.3. We get 2.3 that looks like a number, but it isn't. How can we prove that this is not a number? Well, let's say we want to add, just for giggles here, I'm going to say sum equals radius plus 1. So I'm just going to add 1 to it. Let's see what happens if I try to run this program, right? And right away, let's go ahead and put a radius. Let's say we put a radius of 6.1, right? So watch what happens. There, we get an error. And what it says that you can only concatenate strings. Why? Because a radius itself is a string. So you're trying to force an integer and concatenate it to a string. Now, what if that 1 was a string? Then this would not be a problem in terms of concatenating strings. So watch how this works. And let's go ahead and put 6.1 again. And notice we didn't get an error. We didn't do anything with it. But what we've done here is we've added two strings together. And that's because radius itself is a string. Now, what should we do with the radius? Well, you really need to typecast it to a float. And that's what we mean is you could convert it to a float this way, or you could do this. Now that I have it already as a string, I can force it back into a float by doing this. So radius, let me just write down radius here. Here you go. So my radius now is a float. Now if I try to run this, I'll get an error because now radius is a number. Now watch this. So 6.1 again. And it says unsupported operand, float, and str. Why? Because 1 is a string. So let's remove the quotes around that. Let's run it again. And 6.1, we should have no problems. Okay, so let me just remove some here. We don't need it. Okay, that was just for the purpose of testing. So we can create 2 lines, one to use or to extract the input from the user, and then convert it to a float. Or you can combine it in one statement, float, and then close parentheses, and then you don't need the second line here at all because that combines both of them together. So initially, this is a string, and then it becomes a float, and it's stored as a float. Float, again, is a number type, right, with a decimal point, and it will be stored in radius. Voila. So now, let's go ahead and process for area and circumference. So I like my variable names to represent what they mean. So area. So I'm not going to call it A or any other fancy names other than what it is, area. And I'm going to do pi, which is 3.14, okay, times, and this is an approximation, radius. Why an approximation? Because my pi itself is an approximate value. We know it's a little more than that, so we'll have to get a little more precision. In our next version of this program, we're going to see how we can do this a little better. So times radius. So this squares the radius. All right, so we have radius times 3.14, which is really this formula right here. And how about circumference? Again, so circumference equals, and that would be 2 times, and pi, again, as an approximation, 3.14 times radius. Okay? Again, our radius is known as radius, not r. This is just for demonstration purposes of the formula, right? So we know that r here really represent radius, but the true variable we're dealing with is radius. So now, can we output the area and the circumference? Yes, we could do that. Print. And we can do it one at a time. The area equals, and you can do this, and area, okay? And we're going to do another line where to print the circumference, or the perimeter of the circle, the circumference equals, and we're going to use the circumference variable right here. Okay. Now let's see how this works. Let's run it. We're going to enter that 6.1 we were playing with before. Here you go. And there you have it. So we have the area is 1168394. Now remember, in this program, I didn't do any rounding up to a single digit or 2 digits. I'm just leaving it raw. But okay, but is there a better way to do this program? Is there a way to where, let's say, because we have formulas where we have to multiply something by itself. Especially, let's say we had a radius to the power of 6. Well, then you'll have to multiply radius by itself 6 times. You know, let's say you have a formula that requires that. And let's say you missed one of them, or you added an extra one. Well, you're going to get the wrong result. So is there a way to make this a little easier? And is there a way to use pi that is a little more precise than just 3.14? The answer is yes. And here's what we're going to do. We're going to change all this. So I am going to remove the formulas here. We're going to come back to them. And now if I do that, now notice these will become red here because I don't have these variables don't exist, right? So notice before they existed. But I'm going to use them after I I do something very important here. So watch what I'm going to do. I'm going to import math. This is called a module. And math has a lot of methods that I could use, or functions. So what can I use? Well, let's go ahead and do the area. And we know it's pi. So we're going to use math dot. And notice one of the things that it will supply you is the actual pi. So let's click on that. Times. And we're going to do now, what we're going to do is we're going to raise radius, okay? So to 2, right? To an exponent of 2. Math dot, and I'm going to do pow. Do you see this? Power. And it takes 2 arguments. One is the radius, and number 2 is what is it you're raising it to. All right, so let's focus here. So I have math.pi. So math.pi. So as long as you have math as a module, you can do this. You can extract the pi that's already pre-designed or pre-canned in the math module. And you can use this special method or function called pow that exists or has been predefined in the math module. Somebody created it for you. We're reusing that code. And you're going to put the radius in it as a parameter, plus the second parameter will be the actual exponent. What is it you're raising it to? I'm squaring it, right? So it's a 2. Great. So how about circumference? Circumference. And we're going to make it equal to, and notice we have a 2, so we're not going to modify that. And then math.pi again, right? So, and then times the radius. Now let's see how our program behaves. And let me see here, math.pow. Somehow it disappeared on me while I was typing, so let me do radius. And 2. Now the reason I knew something was wrong is right here I get messages that says something went wrong. So if, for example, this was missing and I kept going, notice I have a little tilde in red, and I got something here that's saying, hey, you know, you've got something on line 11 missing. So be aware of that, okay? Okay, so by clicking on it again, that message disappears again. And if you're not sure what function you use, just hit dot, and you will see pow is right here. And we're going to enter again radius, comma 2. Okay? And that's the intent of our program. Notice now I have a check mark in green that says this program is just fine. Go ahead and run it. So let's use that same value we did, 6.1. And there you have it. Now we got a little more precision here, and again we need to round this output to a single or 2 decimal points. And the reason you're getting that much is because now it's using the actual pi value. Now if I wanted to see what pi value looks like, print this is what pi looks like, and we're going to print it. So watch what I'm going to do here. Math.pi. I just want to see what it looks like right here after I enter the radius. Okay, so let's go ahead and do that. Let's say we enter 1.1. And you can see here that pi has that much precision. Okay, no wonder my outputs had to follow the same length in terms of precision. So what can we do? Well, you can round this up, right? We've seen how to do that. So I'm going to let you exercise with that, or create your own version of the program based on a previous lesson we've covered, and modify area and circumference, or do something here within the print statements where it will be, the output will be either 3.8 or 6.9 or whatever you round it up to. Okay? All right, so I'll see you for the next lesson.